All right, let's get into it. Today, we're basically cracking open a cosmic cold case. We've got a mysterious star cluster, a crime scene that's been obscured for decades by a thick veil of cosmic dust, and a puzzle that has had astronomers scratching their heads for a very, very long time. Just take a look at this. This is Messier 29. It's this gorgeous collection of young, superhot stars. Some people even call it the cooling tower cluster. It's way out there, about 5,240 light years away, hanging out just south of the star Gamma Cygni, right in the heart of the constellation Cygnus, the Swan. I mean, it's a beautiful sight, right? But here's the big question, the one that kicks off our whole investigation. Is this picture really telling us the whole story? Or is there something hiding in plain sight, something that's totally warping our view of reality? And that brings us right to the heart of the problem. You could call it the case of the obscured cluster. And to solve it, we first have to understand the crime scene itself. You know, when you look at the cluster like this, all by itself, it seems pretty straightforward. It's just a nice, tight little group of bright stars against the black background. Seems simple enough, doesn't it? Yeah, not so fast. Because when we pull the camera back, the whole picture changes. I mean, it changes dramatically. See, Messier 29 isn't just floating in empty space. It's buried deep inside the Great Cygnus Rift, a gigantic, thick lane of interstellar dust that literally splits our view of the Milky Way. And this is the crux of our mystery. This cosmic fog isn't just some background decoration. It's physically between us and the cluster. It's like trying to look at something through a really dirty window. It scatters the light, it absorbs it, and it makes it almost impossible to figure out what's really going on in there. And this isn't some new discovery. That cosmic dust has created a scientific cold case file that's just packed with decades of confusing and, frankly, totally contradictory evidence. Hey, don't just take my word for it. The astronomers who wrote the paper we're looking at said it themselves. For years, one study would come out saying one thing about Messier 29's age or distance, and another would say something completely different. The clues just weren't adding up. So, here's how this dust works as a perfect disguise. First, it makes stars look way dimmer than they actually are. Second, it makes them look redder. Astronomers call this extinction and reddening. And when that happens, you can't tell a star's true temperature or its real size. If you can't get that right, forget about calculating the cluster's age or how far away it is. The whole thing becomes a big question mark. But, you know, every great detective story has that aha moment, that one breakthrough. For these astronomers, that breakthrough was a brand new forensic tool, a clever way to finally see right through the disguise. Say hello to the Vilnius photometrics system. The best way to think about this is like a pair of high-tech CSI goggles for looking at stars. Instead of just seeing light in broad strokes like we do, this system measures starlight in 7 very specific, very narrow slices of color. And here's the genius of how it works. By measuring light in those 7 colors, the astronomers can create what's basically a unique light fingerprint for every single star. Then they use some really clever math to digitally wipe away the smudges from the dust, giving them a clean fingerprint. They run that clean print through a massive database of known star types, and bingo! They get a positive ID and the star's true identity is revealed. So now they're armed with this incredibly powerful new tool. It was time to launch a full-scale investigation to gather all the clues they needed to finally crack this case wide open. And this was no small-time operation. We're talking about an international team using 3 different telescopes to map out a huge chunk of the sky around Messier 29. The area they covered was about 6 times bigger than the full moon. And each telescope was crucial, letting them get a complete picture of everything from the crowded center of the cluster to the sparse areas way outside it. And when I say international, I mean it. This investigation brought together data from Lithuania's Milasius Observatory and 2 different sites in Arizona, the U.S. Naval Observatory, and even the Vatican's own Advanced Telescope. A truly global team for a galactic-level mystery. And get this, just look at that number. In the end, they didn't just look at a few stars here and there. They painstakingly measured and cataloged 1,752 individual stars. That is just a staggering amount of detailed detective work. So, the big question. After all of that observing, all of that data crunching, all of that analysis, did they actually crack the code? Well, the answer is a huge, resounding yes. Here are the results in a nutshell. Using their new system, they were able to successfully figure out the true nature of about 70% of all the stars they looked at. For over 1,000 stars, they completely stripped away the dust's disguise and saw them for what they really were. And the end result of all this? They created the most detailed, most accurate catalog of the stars in this entire region, ever. All those confusing, contradictory studies from the past, they could finally be put to rest. The cold case was, at long last, solved. And that brings us right back here, to where we started, looking at this beautiful cluster. But it's different now, isn't it? We're not just looking through that dirty window anymore. Because of some absolutely brilliant forensic astronomy, we finally get to see Messier 29 for what it truly is. It really leaves you with a final thought, though. If it takes this much work, this massive international effort with specialized tools, just to solve a puzzle in our own galactic backyard, what does that mean for the bigger mysteries? It makes you wonder, what incredible new tools, what new ways of thinking are we going to have to invent to crack the codes waiting for us at the very edge of the universe?